Hello everyone, I am Albert Forsen. I welcome you to online lessons in astronomy. The topic is the tools of astronomy. In our previous lessons, we had lessons on the solar systems, our place in the universe, and also on electromagnetic spectrum. Today, we will be looking at the following areas. So by the end of this lesson, we will be able to identify and explain what is astronomical instrument. We will also be able to explain the differences between ground-based telescopes and space-based telescopes and their applications. We will also identify some basic components of astronomical telescopes and their functions. We will also appreciate how a radio astronomy telescope operates or observes. And we will be able to appreciate the brief history of the Ghana Radio Astronomy Observatory. So, what tools do we need to observe the universe around us? What is your guess? Okay. So, which of the following tools do we need to observe the universe? Is the answer A or B, C or D? Which of them? If you get it right, well done. The answer is C. Now, astronomical instruments are the tools used to observe objects and phenomena that occur in space. And typical example is the one we just saw, that is the answer C. Now, we will talk about the types of astronomical telescope observations. There are two main types of astronomical observation, and these are: one, ground-based telescopes. And these telescopes are telescopes that observe the universe or observe the sky from ground. So typically they are built on ground and observe the sky. And example of such telescopes are the ALMA Observatory Telescope and the Meerkat, which is the precursor for the Square Kilometer Array located in South Africa. And the second type are the space-based telescope. These are telescopes built in space to observe from space or observe the ground or the earth from space. And typical example of such telescope is NASA Wide Field Infrared Survey Telescope. And another one is also the NASA and ESA Hubble Space Telescope. These are typical examples of space-based telescope. So, again, why do we need these telescopes? Either the ground-based telescope or the space-based telescope. We need them because we need to observe the universe around us as the solar system, as the galaxies. Why do we observe them either in the form of the solar system or in form of galaxies? It is because we want to understand what we see very well and also do exploration, explore the sky like we have never done before. These are some reasons why we have telescopes to observe the galaxies and observe the solar system. And another reason why we need them or we observe them is also to predict what is going to happen in form of asteroid and also in form of comets. So observing them will give us a kind of understanding of what is going to happen ahead, and if there's anything we need to do or prepare, we must do. Now, talking about types of telescopes in terms of the construction. So we learned about the type of radio astronomical telescope observations. So both telescopes we heard about, we have two main basic types of them. One could be in form of refractors and other also be in reflectors. So refractors and reflectors. Refracting telescope, they are type of optical telescopes that uses a lens as its objective to form an image. And the typical example is the one we are seeing in the picture, and on the top. And the block diagram or line diagram of that such telescope is what we see with the eyepiece or the lens here, and we see the objective lens. This is the lens. So when a light falls on this, the light refracts to the eyepiece. So that is a typical example of the telescope we are seeing here, and that's what we normally use here. And the other type, which is the reflecting type or telescope, they are also type of telescopes that uses a single or a combination of a curved mirrors that reflect light and form an image. And a typical example of such telescope is the one we see here. And the line diagram or block diagram of such telescope is the one we see. The main reflector receives light or coming waves, falls on it, and the light reflects on the sub-reflector and back to the waveguide. We will be seeing more of these type of telescopes and their parts or how they function very well in the next two topics. Telescopes and collecting light. Telescopes and collecting light. So whether someone realizes it or not, electromagnetic waves play a very important role in our lives. And these are the electromagnetic spectrum shown here. In our previous lessons about electromagnetic spectrum, we learned about the various electromagnetic spectrum. But here are they again, and we are going to look at this electromagnetic wave and the type of telescope that observe each of them. So we have radio here, and we have microwave, we have infrared, we have ultraviolet, and we have Xray and gamma ray. The first one is radio telescope. So radio telescope are the telescopes that collect electromagnetic waves, which is radio, or collect radio electromagnetic waves. So this type of telescopes collect only radio waves. And typical example of image produced from such telescopes, radio telescope, is the one we see here, and another one here. The next one is infrared telescope. These telescopes are type of telescopes that collect only infrared waves or infrared electromagnetic waves. And a typical example of such telescopes we have is Wyoming Infrared Telescope from the University of Wyoming Infrared Observatory. And the typical example of image produced from such telescope is the one we see beside. Another type of telescope, which is ultraviolet telescope, and these are the telescope collect only ultraviolet waves or ultraviolet electromagnetic waves. So these are telescopes that detect only that electromagnetic wave. And a typical example of such telescope is a Hopkins Ultraviolet Space Telescope. And a very beautiful picture beside it is an image produced from such telescopes. And then we have Xray telescopes. And these Xray telescopes are a type of telescopes that detect or collect only X-ray electromagnetic waves. X-ray electromagnetic waves. And the typical example of such telescope is Chandra X-ray telescope. And beside this, a very, very beautiful image produced from this telescope. And then we have gamma ray telescope and gamma ray telescope. Gamma ray telescope are type of telescopes that detect or collect gamma ray electromagnetic waves. They are the only telescope that can detect or collect gamma ray electromagnetic waves. And typical example of such telescope is Compton Gamma Ray Observatory. Compton Ray Gamma Ray Observatory. And also we can see a very beautiful picture or image produced from such telescope. So in conclusion, these are the various images produced from the various telescopes or various electromagnetic waves collected by a different telescopes. So a typical example of a particular source or particular source, which is a Crab Nebula. This is a supernova star, which has been collected using different telescopes. And these are the images produced from the various telescopes from the same source of image. Now, we now talk about some basic components of a radio telescope, focusing on basic components of a radio telescope. A typical diagram of a radio telescope shown here, which we see a telescope with parts label. And the first thing we see the dish, which is a primary parabolic reflector surface or a dish. And we also see the sub-reflector, we see the feed horn, we see also the incoming radio wave, which we learned about already, radio wave. So these radio waves fall on the main reflector and reflected back to the sub-reflector, directed back to the feed horn. And the processes happens to the computer or the receiver. The last or the final result is the beautiful image. So follow me and let's delve into this one by one and see the function of each component into detail. So we have the main dish, we have parabolic dish or parabolic reflector. is also known as the main reflector. The function of this reflector is to collect electromagnetic wave. The function of this parabolic dish or the main reflector is to collect electromagnetic wave. Then we have the sub-reflector. The sub-reflector. The function of this sub-reflector is to direct the electromagnetic waves from the main reflector. Is to direct the electromagnetic wave reflected from the main reflector. Now, the next part or component is the waveguide. The waveguide. The main function of this waveguide is to guide the electromagnetic wave collected from the main reflector, directed by the sub-reflector, and guided by the waveguide. So the function of the waveguide is to guide the electromagnetic waves. Now, so we see here the labeling of all the three that we heard about and their functions already: the main reflector, the sub-reflector, and the waveguide. Now, the next component is the feed horn. The feed horn. The feed horn, the function of the feed horn is to transform the electromagnetic waves collected from the waveguide into voltages and current. The function of the feed horn is to transform the electromagnetic waves into voltages and current. Then the next part from the feed horn is to that is the analog to digital converter part, ADC, or also called as receiver. The function of this receiver is to digitize the voltages and the current collected from the feed horn. From the ADC part, then we come to the digitization process or digitization process. So this is where from the ADC part, which digitize the voltages and the current received in this form, digitize it into a digital signal where our receiver or the computer can now recognize as zeros and ones. And then the next thing we see, or the next part, which is the display and system analysis of results. So what we see next is the display of the analysis of the results after the digitization, where our computer can read or recognize the zeros and ones in the digitization form. So this is what we see. Then the next thing is to see our beautiful image of such a source or celestial source that we are looking at, or we focus our telescope or the main reflector. So meaning that the main reflector is looking towards or collecting electromagnetic waves from this source. So this is what our telescope or main reflector is looking at. So this is a beautiful result that we have here. That is how the radio astronomy telescope functions. Now, we'll talk about the Ghana Radio Astronomy Observatory, GRAO, located in Ghana and the capital city, Accra, and in Kutwese, and that is Ghana Radio Astronomy Observatory. So GRAO, or Ghana Radio Astronomy Observatory, was inaugurated in August 2017 by the President of Republic of Ghana, assisted by the then Science and Technology Minister of South Africa. Ghana Radio Astronomy Observatory, Ghana, is a 32 meters dish. So when you say the dish has the main reflector, we learned about that the size of it is about 32 meters. So this was formerly a satellite communication earth station antenna, and it was then now converted into a radio astronomy instrument or telescope. So a few more about Ghana Radio Astronomy Observatory. It operates at frequency of 5 gigahertz and to 6.7 gigahertz. And another important thing we also have to look at, we'll talk about the angles of this telescope. When we talk about azimuth, it turns clockwise 360 degrees. That is the azimuth elevation. That is azimuth elevation. It turns, or it returns on each angle clockwise 360 degrees. That is the operating angle. And we have elevation of 180. So it sees the horizon from 0, raised up to another side of it. So up to 180. That is the elevation from up or from down, up, down. It also has the operating angle of 180 degrees. And it's also very important to note that the Ghana Radio Astronomy Observatory is the first operational station in the African Very Long Baseline Interferometry Network. First one in Africa operating. So I encourage you all to book a visit to Ground to learn more of this. As you can see, some of the students visited the Ground, and we can see here they are in the receiver room. As we learned about, we talk about the receiver, and there are so many activities. They can build their own or mini prototype telescope, and also have access to some of the optical telescope we've learned about, and also have that experience. Also learn about the site and some of the other station or the instrument, like the weather station we have. Also, you can also try and build your prototype in your school as your own project. And in the picture, that's where some of the students taking very beautiful pictures as they visited Ground. So I encourage you to book your visit today and learn more. I thank you very much for watching, and I encourage you to watch out for the next lesson. Thank you. Bye-bye.